Hi everyone, my name is Lan. Today I'm going to talk about my thesis topic, crop yield simulation using statistical models. For the coffee context, my research is under guiding of Dr. Philippe Auret from Paris Observatory. In this presentation, I will introduce the overview of the project and the reason why we choose coffee as one crucial crop to work on. Then I will describe the dataset that will be used. Finally, some discussion about difficulties of coffee study and perspectives of the project will be mentioned. There are three main objectives of the study, which are first to measure the sensitivity of crop to the weather conditions, and then to develop statistical yield models. We also want to estimate climate change impact on the coffee yields. Concerning the topics, so why we choose coffee among many other crops? As we all know, coffee is almost one of the most important beverages. For instance, for your breakfast or for the afternoon break, there are more than 2 billion cups of coffee are consumed every day. Another reason is that 90% of coffee production takes place in developing countries, or in other words, coffee is the major export commodity for a lot of developing countries, including Brazil, Vietnam, Colombia, or Ethiopia. And last but not least, previous studies show that coffee is highly sensitive to the weather and the climate change. So, to be able to study this topic, we will use two main datasets, one for socio-economic data, including the crop data and the geophysical properties. And the second dataset are the weather and climate data, which come from ECMWF, or the European Center for Medium Range Weather Forecast, ERA-5 And also in the future, other satellite data or in-situ measurements could also be taken into account. And in this figure, I would like to show the availability of coffee yield data that we was able to gather. Although we have not obtained all the data for the main coffee exporters, but we have quite good data for Brazil and Vietnam. At the first and the second administrative level for long time periods, and different parameters such as the yield, areas, and productions. In some countries, we have very little data in such periods, like for India, for Peru, or Tanzania. But we all know that the dataset is strategic and not easy to obtain at once. So in parallel with other works, we will try to complete this table as much as possible. And here I would like to show the example of coffee yield in kilogram per hectare for the two countries, Brazil and Vietnam, in 2017. And we see that different colors showing different values of the yields. And in Vietnam, especially in the central highland in the south part, people grow mostly Robusta, thus the yield is clearly higher compared to Arabica coffee yields in Brazil. For the weather, we used the one from ECMWF. Here we consider the newest version, which is ERA-5 land, or the land component of ECMWF reanalysis files. This dataset provides us the grid data at a global scale of 0.1 degree or about 10 km of the horizontal resolution at monthly or hourly scale. And the left figures show the examples of ERA-5 land temperature at 2 meters. Other parameters are also available, like precipitation, soil moisture, or solar radiation. Although the project is very interesting, but there are several difficulties that have arisen since we started these projects. So first of all, there is a limitation of crop datasets. We often have a very low number of samples. For instance, they are available for only 20 or 30 years maximum. This problem will bring a lot of difficulties for statistical models. And another difficulty is the complexity of the coffee. As we know that most of coffee growing countries are very close or near the equator. So we expect to have the same or somehow similar profiles for coffee cultivation. But actually, each country has a very distinct or different stories. So firstly, in terms of coffee type, which could be Robusta or Arabica, or a mixture of the two types. Different types, in reality, different types bring out to different coffee phenology. Furthermore, the coffee plant is complex itself. Since there is no distinct crop season, the vegetative growth happens at the same time as other processes, even during the harvest time. And another difficulty is the farming system. So this true image shows the Robusta cheese in Vietnam in the two methods of cultivations. The first one is synchronized and the second one is segregated, which means that they can grow coffee alone or they mix them with other crops, black pepper for instance. So we could have the setting impact in this case, and it means that different methods will show different impacts of the climate for the coffee and for the yield in general. And also there's a difference in the harvest times. So this example of Colombia shows perfectly how complex the coffee tree is, because here in Colombia, only Arabica coffee is cultivated, but clearly we see that they have different times of harvesting during the years by different color in the figure. And also we see some places, even they have 2 times for harvesting the principal and the minor harvest. So it's really state dependent. So in perspectives, we hope that we can overcome all the difficulties of the coffee in order to build statistical models for yield estimation, and then we can study the impact of climate change on the crop yields. Finally, with this project, we can contribute to Sealand database some interesting data like the crop data and crop models, especially for the coffee. And thanks for your attention.